In the last lesson, we talked about how to convert a decimal into a fraction into a decimal. What we're going to talk about in this lesson is how to go the other way. So if I have a decimal, how do I turn that decimal back into a fraction? Before we talk about that, though, we're going to call a little bit of a timeout so that we could talk about what type of numbers we've started working with. So there's some vocabulary that goes with the different types of numbers that we've been working with, both in the last chapter and also heading into this chapter. So there's some connections with the different types of numbers. So numbers can all be classified into different types. So the most basic number out there is a natural number, and its symbol is a capital N. So each number also has its own symbol. So natural numbers are what we think of as counting numbers. So when you think of counting numbers, you would think of the numbers that you first learned when you were little, starting with 1, 1, 2, 3, 4, 5, and so on. So those are natural numbers. And I'm going to kind of start building a little diagram over here just so you can kind of see what happens with this. So we can expand natural numbers out a little bit. So natural numbers are kind of the most specific, simplest set of numbers that we have in math. If we expand those out a tiny bit, then we get what we call whole numbers. So the symbol for a whole number is W for whole number. So whole numbers are like natural numbers. The only thing is we've expanded those out a little bit. So now we're including 0. So whole numbers are basically natural numbers plus 0. So whole numbers would be like this: 0, 1, 2, 3, and then it goes on. So natural numbers, all natural numbers are also whole numbers. But not all whole numbers are natural numbers because 0 is not a natural number. So if we were to build a diagram, it would kind of look like this. Natural numbers are inside the whole number bubble because they are whole numbers. But not all whole numbers are natural numbers. So we've got 0 kind of hanging out here. 0 is a whole number, but it's not a natural number. If we expand that out a little bit more, then we get what we were working with in our last chapter, and those are integers. Now, integers have their own symbol, and you might be thinking, well, if a natural number is n, a whole number is w, is an integer I. It actually is not, and that is because the I is stolen by a different type of number that we're going to talk about later this year. Later this year, we're going to talk about irrational numbers. So the symbol I gets taken by irrational numbers, I for irrational, which means we can't use I for integers because it's being used by a different type of number that we're going to learn about later. So instead, integers ended up with a different letter, and it was decided long ago that the letter for integers was going to be a capital Z. So integers we get if we expand whole numbers out. So if we expand whole numbers into the negatives, now we have integers. So integers are whole numbers, but they can also be negative whole numbers. So if we were to keep building on our diagram, we could add another bubble out here for integers. So whole numbers are in the integer bubble because all whole numbers are integers, but not all integers are whole numbers because the negatives, so -1, -2, going down into the negatives, going down that way. So all of those are integers, but not whole numbers, because whole numbers do not include 0. Now we can expand that out one more time, and we get the numbers that we're working with in this chapter. So integers in the last chapter we said are whole numbers, which informally we understand means no fractions, no decimals. So if we expand that out a little bit, then we get what's called a rational number. And again, if you're thinking, well, is the symbol for rational R? It's not, because again, it gets stolen by a different type of number that we're going to talk about later called a real number. So real numbers use the symbol R, which means we have to use something different for rational numbers. So it was decided long ago that the symbol for rational numbers would be a Q. So integers and rational numbers, you just have to kind of remember Z and Q. Those are the only two that aren't just the first letter of whatever their name is. So rational number is what we've been working with. We've been talking about, and we're going to keep talking about today, about how to go back and forth between fractions and decimals. So that means that nearly every, and again, later this year we'll talk about which ones can't, nearly every decimal has a fraction form. So that means that nearly all of these are what we call a rational number. So a rational number is any number that has a fraction form. It can be written as a fraction. So of course, fractions are rational numbers because that's part of the definition of a rational number. Most decimals are also rational numbers. So if you can turn the decimal into a fraction, which we're going to talk about how to do that today, then it is a rational number. Natural numbers, whole numbers, and integers are all rational numbers because any whole number can always be turned into a fraction by just taking it and putting a 1 under it. So 5 is a fraction, 5 over 1. So that means all of these other things we've been talking about are also rational numbers, but now we've also introduced decimals into the mix because decimals can be written as fractions and fractions themselves. So it would look something kind of like this. We kept expanding our diagram. So all of these other things go in the rational number bubble because they're also rational numbers. But the things that would be out here would be anything that's not a whole number. So things like 1/2 or 0.3 repeating. Those aren't whole numbers, but they are rational numbers because they are fractions or can be written as fractions. So these are different types of numbers that you should be aware of, some vocabulary that you should know, that you will be held accountable for because it will come up again later. But it was worth stopping to talk about that vocabulary because it's what we're working with. We were working with integers in the last chapter, and now we're working with rational numbers in this chapter. So they are connected because all integers are rational numbers. So now, last lesson we talked about how to turn a fraction into a decimal. What we're going to actually talk about in this lesson, now that we've taken a time out for some vocabulary, is how do I put it back? So if I have a decimal, how do I turn a decimal back into a fraction? How we do that depends upon the type of decimal. So if it is a decimal that has an end, so a decimal that does not repeat, so we're going to call that an ending decimal. Ending decimals are not so bad at all to get turned into a fraction because you just need to look at the place value. And the place value basically tells you what that decimal looks like as a fraction. So I'll show you what I mean by that. So we need to remember how place value works with decimals. So after the decimal point, we have all of these different decimal places, and each of them has their own value. So this is the tenths place, or 1/10. This is the hundredths place. the thousandths place, and it just keeps going out by multiples of 10 because our number system is built on multiples of 10. So then we would have the 10,000ths place, the 100,000ths place, and if you got out really, really far, after 100,000ths comes 1 millionth, so this would be the 1 millionths place. So we can look and see whatever our ending or how far our decimal goes out, and we can look at whatever that place value is, and that basically tells us what the fraction is. So for example, I'm going to drop a fraction into here. So 0.423. So the furthest out this goes is the thousandths place. So that means that turned into a fraction, this would be in thousandths. And then I would just take that part after the decimal, and that turns into my numerator. So 423 thousandths. So that gets it into a fraction, and then from there, if you needed to reduce it, then you could reduce it down. So ending decimals, basically what it comes down to is look at the place value. So what it's going to end up being, if you want an outline, is the numerator is going to become everything after the decimal point over whatever the last decimal place is. So in this problem, we went out to the thousandths place, so we used 1,000 as our denominator. And again, that gets to change into a fraction. Once it is a fraction, then you should look at your fraction and see if you can reduce the fraction from there. If you can reduce it, then you should reduce it. So that's how you deal with an ending decimal. Everything after the decimal point becomes the numerator, and the denominator is whatever the last decimal place is. Now, in the last lesson, we learned that all fractions turn into one of two decimals. They turn into either an ending decimal or they turn into a repeating decimal, which means we need to talk about how do I turn a repeating decimal back into a fraction. So turning a repeating decimal back into a fraction is a little trickier, but there is a process or a set of steps that we can go through. So I'm going to use this repeating decimal as an example. 0.42 repeating. And I'm going to map out the steps that we would need to go through to turn this into a fraction. So the problem with the repeating decimal is that it repeats. We somehow have to set aside the fact that it's repeating in order to figure out what's going on and turn it into a fraction. So our first step, we are actually going to use a little bit of simple algebra to help us turn this back into a fraction. So we're going to set up a very simple equation that we're going to use. And our equation is so simple that it literally is just going to be n equals our starting decimal. So the outline for that starting equation is always just n equals whatever decimal you're trying to convert. But now we're going to do some things to that decimal. So we're going to take this decimal and we are going to multiply by 10 for each number after the decimal place. So in other words, we're going to multiply by 10 for each number that is in that repeat bar. So if we have two numbers in this one that are in that repeat bar, we have to multiply by 10 once for each of those. We'll say multiply once for each number in the pattern. So this has it's a 2-number pattern, so we would have to multiply by 10 twice. So we're going to clean this up a little bit. Multiplying by 10 twice, times 10 and then times 10 again, we're going to end up just multiplying by 100. So rather than doing it in 2 steps, we can do it all at once. You just have to keep track of how many times 10s you need, and you can do all of that at once if you like. Now, this is an equation. So the rules for working with equations say that if I multiply one side, I have to multiply the other side too. So I can't make one thing bigger and not make the other thing bigger too. Otherwise, they won't be equal anymore. And I put an equal sign there saying they're equal. So I'm going to multiply by 100, but that means that I am going to have to multiply both sides by 100. So every time you multiply by 10 in our number system, it moves the decimal point over. So if I multiply by 100, I would end up with moving this decimal point over twice, but remember, it keeps repeating. So I would end up with 42.4242 repeating. So if I multiply that side by 100, basically, I'm just pulling one repetition of the pattern out of the pattern and putting it in front of the decimal point. But I multiplied by 100, so now my number is 100 times bigger. So I have to put the 100 on the other side too. Now, this is where we're going to do something a little bit tricky. And we're going to call this subtract the starting equation, or subtract the original number. So here's what's going to happen. So this is my 100 times bigger version of my number. So the number multiplied by 100 equals 42.42 repeating. So what we started with was right here. So we're going to take that, and we are going to come down here, and we are going to subtract exactly what we started with. So you have to remember something really important, because I put an equal sign here. I'm saying that the 0.42 repeating and the n are worth the same thing. They're interchangeable. So everywhere where I have an n, I could put a 0.42 repeating instead. So I'm going to take that starting statement, and I'm going to come down here, and I'm going to subtract it. So the original decimal was 0.42 repeating, so I'm going to subtract it. But over here on the left side I don't have the actual decimal written out. I have the variable, the n, that I came up with to represent the decimal. But remember, n represents that decimal. So if I subtract n, that's the same thing as subtracting the decimal itself, because at the top, the part highlighted in green, we said that those two things are exactly the same. So we have to subtract matching things. So on here, I'm going to subtract n. So if you look, literally, we ended up just taking our equation, our original equation down, and copying it down and just subtracting it. But now we have to actually do the subtraction. 100n minus 1n leaves me with 99 of them. And over here, this is where something convenient happens. What ends up happening on the right side is that I'm basically just subtracting the part that's repeating. 42.42 repeating minus the repeating part is basically just going to wipe out the repeat and leave me with 42. So what this did, this idea of, okay, I'm going to multiply the equation to make it bigger and then subtract out the repeat, I just got rid of the repeat. So now I have a one-step equation I can work backwards from, and if I work backwards, it's going to give me my fraction. So n times 99, the way I would undo that would be to divide by 99. So that means that my fraction is 42 divided by 99, or 42 over 99. And then reduce. So always check and see if you can reduce your fractions. So in this case, I can reduce this fraction. Everything is divisible by 3. So my final fraction, 42 divided by 3, is 14 99 divided by 3 is 33. So 0.42 repeating is a decimal, or in decimal form, if I rewrite it as a fraction form, would be 14 over 33. So again, the steps to convert a repeating decimal back to a fraction can be a little tricky because it's a lot of steps, but the steps are all mapped out. Set up your equation, multiply by 10 for each number in the pattern. Take your scaled up equation and subtract the original things you started with out of that, and then work backward, and it will give you your fraction. From there, all you have to do is reduce.